讨会非常难得，是由来自美国微软总部的微软研究院 Stewart Tansley 博士，还有相关的研究人员，正式对台湾的学术界介绍 Kinect for Windows SDK， 将会协助您了解如何运用这个 SDK 来建立更为丰富的自然人机界面。今天比较不好意思的就是，因为我们现场有太多丰富的内容想要跟来宾分享，所以呢，今天的会议并没有安排特别的休息时间，这点要请大家多多包涵体谅。那如果期间大家想要休息的话，都可以随时到外面去，我们外面还是备有茶水。在活动的一开始呢，我们很开心的可以邀请到台湾微软开发工具暨平台推广处总经理刘念真刘总经理来为我们致欢迎词，让我们掌声欢迎刘博士上台。
各位来宾好啊，这个 Connect for Windows 啊，那 Academic 我们刚刚跟那个Dr. Tansley 来谈，就是说我们大概是从6月的时候，从 MSR 开始推广哈。那其实，在台湾其实不管在业界哈，还有在学界，其实我们看到其实很多人对这个有兴趣啊，所以我们呢还有跟Heidi 是我们那个亚洲这个研究院哈，我们就一直的同仁一直在构想说，我们是不是能够找到台湾不管在学术界或甚至有一些业界哈，能够对这个有兴趣的，然后我们把这个 Tansley 找来哈，然后大家共聚一堂来一起做这个研讨哈。所以今天其实我个人是蛮兴奋的，也非常感谢各位哈。我想有一些还是从中南部哈来这边，然后不管是在学校里的 lab 或者是在哪边哈。我想今天像刚刚讲的哈，就是说我们 Keep 是一个等于说大家交流会，中间大家有问题的话，随时举手哈。那没有 break 中间大家需要休息的话，我觉得我们大家可以来relax 来做这个事啊。那我在前面稍微有一点，因为这个机会非常难得啊，所以我们整天会有 connect 在前面的话我想跟各位稍微来不错。来稍微就说跳出来是从 Connect 整个 Microsoft 来看哈，因为我想这个现在的这个 IT 的这个 environment technology 是在变化哈。那 Microsoft 过去给人印象是在做这个 software OK， 尤其 Windows Office 然后接下来我们有很多的 server 的这些 technology product， 然后在 Web 等等啊。那接下来 OK， 在整个 IT 的环境，接下来 Microsoft 在做什么？那我想其实我们在内部很清楚就是说其实现在在总部的 R&D 大家可能不晓得，就是说大概有绝大多数的 R&D 的 force 其实是在云端，在 device 上。我们当然会去 maintain 我们的原来的 software OK， 但是 cloud 跟 devices 我想2年前 Steve Ballmer 先生来就我们的 CEO 讲了一个 3 screen and cloud。大概 3 screen 的话是一个 device 因为我想现在整个 paradigm 到各式各样的 device cloud， 所以从 Microsoft Vision 来看，以后的computing environment 是这样子 OK。那在这里头，我想不管从学术的开发，从 business， 甚至我们从这个咨询的业者的话，我们会朝向这个方向做一个转变。那 Microsoft 也是在做一些 transformation 在做这方面，所以。我看到这个中间比如说这个中间这边的话，其实我们把非常多以前的 software technology move 到云端去，那我们的 Windows 从 PC 即将要展开到各式各样的 device。所以这里头简单来看两个东西，我觉得其实大家可以印象很深，就是 Microsoft 是以 Windows 起家，那这边这句话，其实它目前在做非常多的 R&D 是 extend 这个 Windows 的 technology。to 这个 Internet scale 的这个 Cloud Platform，OK， 那Windows Azure Platform 当然是我们 Microsoft 里头最重要的一个这个云端的这个平台，在这上头可以开发。其实，在过去我们跟不少的学校清大、交大等等，不管在开课、在研究方面的话，有这样子的一个 Cloud Platform， 这是从 Cloud 这个观点来看那从 Device 的来看的话，其实今年。在9月的时候，我自己还有我们很多的同仁也去这个 加州这边来 Anaheim 做一个，其实在 Microsoft 来看我们来看是 Windows 95以后最 significant 最重要的一个Windows 产品是这个 Windows 8那这里头重要的一点就是说，在 Windows 以往的话是以 PC为 centric， 在过去20年几乎都是这样，但在 Windows 8的这个刹那之间，我们希望这边讲 Unified Ecosystem。能够把 Windows extend 到各式各样的 device 平板电脑各方面，其实我们phone 方面也是一些 Windows technology， 甚至到 Smart TV 等等。那这个的好处是，我们希望说在这整块里头有一个非常uniform 的 device driver， 有一个非常 unified 的管理方法，有 unified 的 security 的机制，有 unified 的 development platform。因为我们看到，其实现在我们非常可敬的很多的对手 ，Apple、Google 等等，在 Cloud、在 Device 上，其实是一个做了非常非常好的东西。那 Microsoft 在做这个 transformation， 希望说能够用 Windows， 能够我们讲 reimagine Windows， 能够做到这一点。但是在这整个 platform 能够是用一个很 consistent way 把它串起来的话，我相信对各方面应用的话，会是一个那当然，这里头很重要，谈到 Device 的话，这个。从 user interface 来看的话，对不对？我们从 mouse keyboard， 这是 PC 上头主要的，这个，但是我们会走向非常多 natural user interface， 当然 Connect 这个也是我们一个主要的一个今天的 topic。好，所以其实我这边简单来看，跟各位谈从 Cloud 的 device 在台湾的这个 schedule， 台湾的 time frame 来看，其实。从10月，大家也许有看到芒果机各方面我们跟这个 HTC 合作，在10月初的时候，announce 的芒果机，然后12月刚过就是跟 Nokia 方面，所以基本上我们看这个目前的这一季了我们是等于说把这个首先是把这个我们希望在phone方面是有一些进展那其实，在农历年过后，大概在2、3月左右的话。其实 Microsoft 原来 Windows Office 从 Desktop 上云端就是说 Office 365，简单来讲，它会是在 Cloud 上头的。当然 Office 大家想到是 Word、Excel、PowerPoint， 但实际上包括了 email， 包括了很多 collaboration 的 tool、communication、video、audio 的这些，整个 Office 365 means 365天运转。我想 Cloud 是这种 availability，OK， 那它是一个云端 version Office， 那我刚刚有讲 Windows extend 到 Cloud 是 Windows Azure， 所以这个 parts 其实我们是跟很多的学校跟很多的已经开始做先导计划，但是真正在台湾真正上市的话，可能是在2、3月农历年接下来其实非常重要的其实对 Microsoft 来讲是非常真的是一个关键的 platform 是 Windows 8。那我的部门还有在台湾微软的这个在 Windows 8不管在 phone 方面上头如何开发 application 它的这个 programming model 是什么等等的话，我们会在接下来明年开始一整年的话，可能会有非常多的一些讲所以我想这是大概在台湾不管在 Cloud 在 Device 上头在 phone 上头的一些 schedule 那所以我想这个回到刚刚跟这个Tansley 这个来谈，是说，那我们今天 Connect 跟这个 Cloud 跟 Device 之间关系是什么我觉得等一下，我想 Stewart 会来做一个很重要。其实今天我想 Cloud 在 Device 端，Cloud 在 back end，OK，Device 在前面的话，它因为走向了从 PC out of 这个 desktop，OK，所以说它可能是在任何的环境中出现我们的汽车里头可能是有一个 intelligent device， 我们在任何一个日常生活之下，所以 keyboard mouse 这样子的 user interface 已经不足以支撑以后我们所谓的 pervasive computing 的一个这个环境，因为用的人可能是 general consumer， 他的场合里头并不是在桌上，所以其实 natural user interface 是一个 key 的一个以后的一个 topic。那Stewart 告诉我说，像 Microsoft 的 Connect 和 Windows 这个 Connect 这些 technology 其实是 Microsoft 在 natural user interface 上头的一个 very beginning 的一个东西。那这些 technology 以后会 extend 到各式各样的 device， 以后会有各式各样的 advanced 的这个 technology。所以今天来看的话，这等于说我们在走向这个自然人界面的话，还是一个 very early 的 stage。 好，所以大概我讲到这边，那其实我们今天我们很欢迎哈，就是说其实Stewart 他是刚刚有谈到哈，是在MSR 在总部的微软研究院里头是 Director of Natural User Interface， 所以谈到 Microsoft 的这些愿景哈，他在这个最适当的人哈来跟我们谈。So we'd like to welcome Dr. Tansley to give us an overview.
Thank you very much for that very kind introduction. Well, good morning, Taipei. It's great to see you all. Let me get the right clicker here. We've got too many clickers. Here we go. So I was interested to hear that there's a civil engineering conference going on in this building. My PhD is in artificial intelligence, in knowledge-based systems. It's quite a few years ago now, so this is back in the days when we called them expert systems. But the application of that was in civil engineering, so I'm quite torn to go and see my old friends in civil engineering. So I'm from the Microsoft Research Connections group, which is part of Microsoft Research, and we are a bridging group between the world of academia, professors and students, especially in research, and Microsoft Research internally. A number of us are from that group here today. So what I'm going to be doing for the first part of today, before we get into the real event, which is Krishna Kumar, who will give you a hands-on taste of the Kinect for Windows SDK, if you've not already tried this yourself, or even if you have, he's still going to tell you more about it. I want to give you a little bit of a story around the Kinect for Windows SDK, some of the rationale for why we built this, and really what we see how you can participate as part of this story. Because this is a story for everybody. The entirety of the computer science field and applications of computer science, Kinect is for all of us. So without further ado, let me move on to my slides. Now, one of the things that will be maybe just a tiny bit confusing today, but I hope I will help to explain this confusion today. So we're in a period of transition today. We are speaking from Microsoft Research today, primarily. And Microsoft Research helped make available the Kinect for Windows SDK, and that's why you see a URL which has research.microsoft.com in it, the research site for Microsoft Research. But we are in transition because this is going to be a product from Microsoft, and we're halfway there right now. In early 2012, next year, just in a few weeks' time, essentially, we will have the full product available for Kinect for Windows. And that's been announced, and this is the site. When you go to connectforwindows.org, the current website, you will see that this website, and you will see that's where to download the SDK, it's where to get all the documentation, it's where to get to the forums, all the sorts of things to do with Kinect for Windows. We've even announced that there will be some new hardware, a new device for Kinect, as well as the software. And that's why we say now Kinect for Windows, rather than Kinect for Windows SDK, because the SDK is just one part of the Kinect for Windows product. So there's both hardware and software. So I will, because we're in this transition, I'll be speaking from a research perspective today. You will see research URLs, but the main thing I want you to understand today is it's Kinect for Windows, and it's Kinect for Windows with hardware and software, and this is the website to go to, connectforwindows.org. So now let's tell a little bit about the background story. Some of you may remember the name Natal. Project Natal was the code name for Kinect. Back in June 2009, we announced the Project Natal, and it was at E3, because this was originally just an entertainment technology. E3 is the big computer gaming conference. And the reasons for Project Natal are kind of interesting, because as part of Xbox's trying to figure out how to expand their market, how to get more sales of Xbox, one of the things that they found in talking to their consumers, not only the people playing games, but also the people that could play games, the potential consumers. Often, perhaps our parents, for example, or younger children. Because the game players for Xbox originally were quite well defined. They were hardcore gamers, a very serious kind of gaming community. And this existing gaming community didn't have any problem with a hand controller. But the potential consumers, the people like our parents, they found that it was off-putting to use this hand controller, the device you see on the left. Nintendo had showed that with the Wii, a novel controller for a game could be a really entertaining experience. And they were very successful for a couple of years in the Wii system. But we wanted to take this further. We wanted to imagine, what if you could completely remove the controller, not have any controller, and make you the controller, your own body, the human body, as the device that controls the computer, controls the game machine in this case. And so that concept, Project Natal, was the central idea of a gentleman called Alex Kidman. He had a team in Xbox, and they did some prototyping work. And I'll explain a little bit about how far they got. But to get to this product, just a year or so later, in November 2010, a year ago, almost a year ago and 1 month, when we launched the product, this was just the start of what we see now as a much richer story, originating in this entertainment experience, originating in the idea of having no hand controller for a game. So, do any of you know where Natal, the name, comes from? If you do, I'm sorry, but here's the answer. It's a city in Brazil, and that's where Alex Kidman comes from. Not only did he originate from there, but his concept, and the concept in Xbox then, was the birth of the next generation of home entertainment. No, not just the game, but to transform entertainment experiences much more broadly. And in fact, as we've seen, Kinect is now going outside of entertainment even. So they really were looking very visionary in the Project Natal concept. So the Kinect technology, though, often you think of as that black bar. I don't have one here, but Krishna will have one for his talk. But you've seen this sort of almost iconic black technology. And it would be a mistake to think that Kinect is just that device and the sensors in that device. I'll hold it up. Anybody not seen a Kinect? Here's a Kinect. Thank you, Krishna. But Kinect, the device, is just an array of sensors. And as you know, all of you here, I think, are computer scientists or technologists of some kind or another. You understand that getting information from sensors is a pretty tricky business. They're very noisy. Getting the interesting information out of that signal is difficult, it's challenging. And there's an awful lot of software that goes into this. And so that software provides the brain of Kinect, and that's mostly what we'll be talking about today, and it's what we've given to you in the SDK. We're giving you the brain of Kinect with the SDK. So the story in summary here is that it didn't just come about from that idea of Alex and his team, though. The notion of solving the problem came about from decades of computer vision research, and also computer audio research too. Because we're very keen for you to understand that the Kinect is not just about the vision system, but also about the audio system. And this is where my job fits in with natural user interface. Because Kinect is a tool for building natural user interfaces. Natural user interfaces are ways to interact with computers that fit in with this concept of ubiquitous computing, or ambient computing, or pervasive computing, where computers become immersed in our lives even more commonly than they are today. Today, we still think of distinct computers sometimes when we interact with computer systems during the course of our day. Maybe we're in a car and we're interacting with a computer or computers that are in a car. But that becomes a little bit more seamless with our lives. But we still hold handheld devices when we use a laptop. But in general, the trend is to make computing much more commonly just seamless within our worlds and with our daily lives. And this is where Kinect is helping us interact with this type of computing, because it's part of a natural user interface. It's a more natural way to interact with computers, because this pervasive computing becomes immersed in our natural daily lives. The Xbox did some prototyping work of this concept, going back to computer games for the entertainment scenarios. But they ran into challenges, and they got a certain amount of the way, but they couldn't solve the whole problem, and it was still remarkable how far they got, as I'll explain. So in September 2008, they needed to call up Microsoft Research, which is the internal research lab, the computer science research lab that Microsoft Corporation has. And Microsoft Research is like a giant computer science department, so you'd be very familiar with it, those of you in computer science. We have labs all around the world, and they're doing academic research. They publish in the same conferences that you do, they visit the same conferences they do, publish in the same journals. We're often a good help for the product groups where they've got tough technological problems to solve. We're in general working on future technologies, but sometimes those future technologies we can bring forward into today's reality, especially working and helping our product groups. So we launched the Project Natal concept of June 2009 at E3, as I mentioned, and then in November 4th last year, the retail product was announced for Xbox that was released around the world, including Taiwan. What was amazing was we were very proud of the success that this had in entertainment. It sold 10 million units by March 9th, 2011. And that is a remarkable number for any type of product, because it turns out this hit the Guinness World Record for the fastest selling consumer electronics product of all time. Even amongst all the interesting and amazing technology devices that are in our lives today, this was the fastest selling of them. Very, very remarkable. Let's drill into a little bit more about the technology. So you're all computer scientists of some kind, or you know about computer science. You know that this is a non-trivial problem to solve. You know that some of the problem has been solved, but trying to solve all of this together is non-trivial. So in general, though, in the abstract way, what I'm trying to do from an entertainment experience with Kinect is I'm trying to find where the people are in a video stream. So I'm looking with a camera at a group of people, small group, not as big as this, because the scenario that Xbox were looking at was in a living room, playing a game with a family or a couple or a small group of friends. How can I find the people in that scene? And some of you may know how to solve that using algorithms today. We can do that. You need to separate the people from the background. But you're trying to get to a point where they can be the controller, where they can use gestures, like I'm doing now, like I'm waving, to control the gaming system or the entertainment system. And so you need to find where their limbs are, where the joints of those limbs are, and track them and understand where they are, where they're going. You need to just separate which person is which, because it gets very confusing if you're playing a game with two people and the system doesn't know which person is which, because they'll start interfering with each other's scoring. We can't have that with a game. You need to track the gestures more than just the limb movements. The reason, the extra information there is semantics. You're trying to understand that this is not just a random way, but I'm actually moving my hand in a way that has some semantics, has some meaning, which I can now map to a control. So I want to map those gestures now to a control, to a command for the Xbox, for an entertainment experience. A control in a game, or a control in the audio-visual system, whatever it takes in the Xbox. It's also helpful in an entertainment experience in the living room to do facial recognition, to understand who in the family member or which group of friends that are playing this game, and have a memory there. So recognizing faces is useful, and we wanted to build that in. And also, again, it's not just about the vision system. We think from a natural user interface point of view, it's very natural for us to all speak in general, and the recognizing voices and commands is an important part of that natural experience, if you have that ability. Remember, this is a software problem, and I'm on a computer system, and I still need to run the application. In this case, it's Xbox, and it's playing a game, or it's playing some entertainment experience. So think about this. I need to do all of this, solve this problem in software, but I also need to run the application too. And the same applies on Kinect for Windows. When you write your applications, you don't want all of the CPU to be used up in tracking gestures, separating people from the background, understanding voice commands. You need a lot of your CPU to be run in your application. And that was very true in our design problem. So this was almost like magic in getting this to work. We used machine learning, a classification algorithm. Effectively, though, in summary, this is evaluating trillions of the possible body configurations of multiple people across 32 of their body segments, is the way the algorithm segments it. And we have to do that every video frame. And in the US, and I believe here, that's doing that at 30 times a second. 30 times a second we have to do this. I have to do that on less than 10% of the CPU because I want 90% of the CPU available to play the game, to run the artificial intelligence for the game, to run the graphics, to run the audio in playing the game. So I need to do this effectively 10 times the speed of real time. And now I hope that some of you may appreciate that that's getting to be quite hard. Because it turns out that back in 2007, when we were prototyping this work in Xbox, and then working with Microsoft Research in 2008, that despite decades of computer vision research and also audio research, done both in Microsoft Research and in industry and across academia around the world, the state of the art in how to track human bodies in 2007, it wasn't possible to do this. It was impossible. You could track human bodies. You could do it for a limited set of agilities, a certain amount of movements, a certain number of body types, but you couldn't do it in real time. And Xbox needed it not only in real time, but 10 times real time. They wanted to run it on 10% of the CPU. So Xbox needed their hard requirement to make it an acceptable entertainment experience, let alone using it for Windows and all the other amazing experiences that we're starting to see today, is they wanted to run it for all sorts of motions, all sorts of users. They wanted to make this technology available, if you remember, to expand their market, to make it accessible to all sorts of different people. And that means people of different sizes, different shapes, all sorts of different attributes of people. So all motions, all agilities, 10 times in real time for multiple different body types. They did have a low-cost 3D video camera, a depth camera, a technology license from PrimeSense. That was a key factor in this, but the software is really where the magic happens. And you can learn about this software today. I won't spend time lecturing you today on the details of this algorithm. You can go and read the paper if you haven't already. It won Best Paper Award at CVPR, the big computer vision conference in Colorado this past year. These are the authors of the research and the technology in Xbox that designed the vision system in Kinect. Again, it's not just about the vision system today, but the vision system is a really nice piece of Kinect. And so you can read how we solved that problem and made some breakthroughs in that technology. There's the paper there, there's some supplementary information as well, and a video explaining that work. And I think it's testament to not only the quality of that research and the success of this as a product, but also this is the latest research. This is high-end research. And it's all part of the remarkable story of Kinect. There's some of the best researchers in the world here. They won Best Paper Award about this technology. I won't go into the details, as I say, for time, and I'm sure you can go read this paper and understand it better than I can explain it. But I do want to highlight, for those of you that don't have time to read the paper, or maybe not interested enough, one of the interesting things, though, I'd like to tease out is a curious innovation that happened in designing this algorithm to be very high speed, working on 10% of the CPU. So what the breakthrough in Microsoft Research was, the researchers there on the list of that paper, they had done object recognition research, not so much body tracking research. Now the thing about body tracking is that it's natural for you to think that body tracking is about a time sequence. I'm moving in time, my body is moving, I'm tracking a body over a time sequence. But that's not how the algorithm works. The algorithm works just on simple object detection, object recognition. And it uses a per pixel classifier. So all that means is I'm looking at the depth image, interestingly, only the depth image. Looking at the camera that's seeing only the z-axis, the distance from the camera to the person or multiple people in the room. And for every pixel, it is taking a classification measure of what the probability is of that pixel, each pixel, being part of a human body, and which part of a human body. And that's a pretty amazing breakthrough, that you can do this human body tracking with just looking at the scene using object recognition, object detection, classifying per pixel, not even looking at video. It's just looking at each video frame as a single picture. So the algorithm works if you didn't have a video. The algorithm works just if you have a single picture. Of course, all you get then is a table of numbers showing what the probability is of a pixel being part of some part of the body. But that's essentially how the vision algorithm works. It was a big breakthrough. One of the neat things is it's fast. And so you can get this not only at 10 times real time, but the research paper at CVPR, I think, explains their tests showed this could work at 200 times real time on a regular PC. It's a classifier, it's artificial intelligence, it's a machine learning algorithm. You therefore need to have a big training set. For those that understand about machine learning, this is typically the way that you use this technology. And so in practice, while you can come up with this cool algorithm, to actually make it work, you need to do a lot of work. And that's hard work sometimes. I have to go out to the field, collect thousands of images from tens of thousands of homes with real people in it, because I need to train this not on ideal body types, but regular people like you and me. And we did that, and we used Hollywood motion capture technology, the same technology that you see being used in filmmaking around the world today. I should say Hollywood in Taiwan, of course you have a major film industry in Taiwan too. That technology, motion capture technology, is a great way to capture all that training data. But now I've got an enormous amount of data, an enormous amount of depth video frames, and I need to train my algorithm and make my algorithm work. So this is a non-trivial machine learning problem. I actually had to, in Microsoft Research, we had a technology called Dryad Link. You can get access to this technology today yourself, and it's a way to do a very large distributed processing in an efficient way, to program that efficiently. It works with a big cluster. We still run this cluster today because we're constantly refining this algorithm. We're constantly tuning this algorithm. We make this available through updates to the Xbox, and now through updates to the SDK. So as being part of this SDK, you get access to this latest algorithm work, where we constantly refine this algorithm. Don't forget the audio. It's not just about the vision system. There's another research paper and work on this. There's an extensive parallel set of work. The primary researcher here is Ivan Tashev in Microsoft Research Redmond, where I'm based. He did a really beautiful presentation. It's a 1-hour presentation, so it saves me an awful lot of time talking about the audio algorithm. If you just go and download this presentation, it was done at MIX, the Microsoft conference that happened in April this year. And that talks all about the audio pipeline. So there are 4 microphones in Kinect, and it's one of the nicest microphone arrays you can buy. It's very inexpensive. You get a free Kinect with a microphone array. There's another way to think about it. You can use this 4-element, I'm going to say elephants again. I saw a lot of elephants in another place, but 4-element microphone array. And you can do interesting things because it's a microphone array. You can do things like doing echo cancellation. You can do noise suppression. And you can do things like beamforming to determine the direction of where a sound is coming from. This gives you an enormous amount of power to you as researchers or practitioners, students, whatever, to do your own work in the audio space. Really powerful audio array. So check out that deck. It's nice and technical. It's a good deck. Let's talk about where we're trying to give this technology to you. We have an SDK available. And we wanted to make the SDK available for months. Personally, I got involved in the summer of last year, so I've been working on this almost 18 months now. You can go read another version of this story that's published in Wired magazine. The URL's up in a strange way on the right-hand side of the screen here. But like many stories that are complicated and have lots of different people in, there are many different ways, and many different vignettes, many different types of story that happen. I won't go into the whole of my story, but the details are that many people were involved in getting the Kinect technology out, not only to the Xbox community and people playing games, but another group, a large group of people in Microsoft Research and in Xbox itself, helping to get an SDK out to all of us. After the Xbox product was launched in November, we were working really fast to get an SDK out. The community was even quicker. So the community got into the Xbox, they built their own drivers. It was amazing to see. People got on and built all sorts of interesting applications while we were working on our official SDK. We worked as hard as we could, and we had our top executives. Craig Mundy is the boss of MSR worldwide and a whole bunch of other business units. Don Matrick is the head of Xbox and all the other entertainment businesses in Microsoft. So these two top executives, reporting to Steve Ballmer, they committed us to build an SDK for all of you in February this year, 2011. And they said it would be available in spring. And so we were working hard in Microsoft Research and in Xbox, but particularly Microsoft Research in this case. And finally we made it in June, in the last few days of spring this year, and we released the Kinect for Windows SDK Beta 1, the first beta, in June 16th. Since launch, we are evolving this technology, and we're in transition to the product group to make this a full product. Microsoft Research was just helping out temporarily because we wanted to get this out in particular to students and researchers and professors around the world as soon as possible. We've already had a Beta 1 refresh in August. Excuse me. We released Beta 2 in November. That's also the first anniversary that the Xbox product was released. So it was just a nice correlation. The full commercial release of Kinect for Windows is in early next year, early 2012. Not spring, early 2012. But it may be, I don't know, the last few days of early. I'll leave you to determine which day that is. We haven't committed to another date, but as soon as possible in 2012. You can track the progress of the product group, because it's no longer Microsoft Research doing this work. It's the product group in Xbox that are doing this. They're not just doing it for Xbox, they're doing it for Windows, for all sorts of different applications. And it's also not just for academics and students this time, this is for companies. If you want to start a company, or if you want to go and work for a company, or if you want to build a new business on Kinect for Windows, you can do that from the start of 2012, early 2012, because we will have this technology available commercially. So a little bit of history. This was the original website that we put up as our teaser before we launched. Some of you will be familiar with this. If you've already downloaded the SDK, this is what we launched in June. But this is what you'll see today. And this is our new brand, Kinect for Windows, from the Xbox product group, which are behind this full commercial product, Kinect for Windows. And it includes not only the software and the SDK and all that artificial intelligence software, the video and the audio and so on. It also includes some new hardware. Now the new hardware won't look dramatically different to the current hardware. But it does have some interesting features. For example, it has a near mode, which allows you to get closer in to see the nearer field than the old Xbox technology. So that's really useful for Windows scenarios, because if you remember, the original Kinect is designed for a living room, for playing games in a living room. So the distance range is suitable for a sort of what we call the 10-foot or the 3-meter experience. But often in Windows, I want something closer in. I want to be nearer the computer. And so it's important that we have a Kinect that can look further in. And this now works up to half a meter, 0.5 meters, and even goes gracefully to grace out to 0.4 meters. So it's much closer. Go back to the SDK. What's in the SDK? We have access to the raw sensor streams. You can get the raw data. You don't have to deal with the human body tracking if you don't want that information. You can just use Kinect as a sensor, both a video sensor or an audio sensor. You don't have to use all of the features at one time. And you can build all sorts of interesting applications just using parts of the Kinect device, the Kinect technology. And we give you that access to the raw sensor streams in audio and video. You can use the full skeletal tracker, and you can stand on our shoulders and use all of that training information that we've spent collecting around the world, tens of thousands of people training the algorithm. You can get access to that with a skeletal tracker. And we're refining that all the time, as I mentioned earlier. So by getting on board with the official SDK here, you can benefit from our refinements as we make it available to tens of millions of Xbox users. Now we're going to make it available, the same algorithm, the same refinements, to all of the people who are building on Kinect for Windows. You can get access to all the advanced audio capabilities. I'll let Krishna tell you more about that. He has a really nice demo for that. We've got sample code. There's plenty of sample code available today. You don't have to start from scratch anymore, or just use Krishna's tutorial. You've got, now there's over 100 samples available on our project gallery. So there's some built-in samples to the SDK, just a small number, get you started. They're quite easy to use. But there are now over 120, effectively, projects that you can use as samples on our project gallery. It's easy to install, it doesn't take tens of minutes, it doesn't take gigabytes of files. It's initially for non-commercial purposes, initially for education, initially for hobbyists and enthusiasts, although we will allow early prototyping to happen in companies, because ultimately we want this to be a commercial product. We already announced that we're working formally with 200 companies around the world in, I think it's 20 different industries and 25 countries that are officially working with a preview for the commercial SDK. It works on Windows 7. It does work on Windows 8 as well. I keep on forgetting to update that, but of course it works on Windows 8. Windows 8 will be our future version of Windows. You can use C++, you can use C#, or even Visual Basic. And primarily Visual Studio 2010 is the development environment. There's more information on the website to check that out. There's access to a whole set of training material. Not only is Krishna going to give you a taste, if you haven't tried it already, but you can get access to videos from when we launched the technology in June. It's on the Channel 9 website. Channel 9 is a great community website supported by Microsoft, run by Microsoft, and they helped launch the Kinect technology. It was a really great experience working with them. They also have a site called Coding for Fun, also part of Channel 9. Coding for Fun is our project gallery. When I copied and pasted this picture, there was only 15 projects on that. This was many months ago. The latest one is 120, so I think it's 128 projects. And we asked that these projects have source code as well. So these are where you can get access to many, many different samples. This is not all built by Microsoft, very few of these built by Microsoft. These are mostly built by people like you, built by the community. People that are exploring what you can do with the Kinect for Windows SDK. So do check out this site, but I also invite you to participate. If you have an idea, if you would like to see your project on this site, then it's very easy to do. Just email us. So we were also almost creating a movement here, a community of people that are exploring the Kinect technology and applying it to all sorts of different scenarios. Some of them are natural user interface. Some of them are about novel user interfaces that are perhaps more natural for us to enjoy, like the original design of the Xbox and its entertainment experiences. But some people are using the Kinect as a sensor array and using just the video or just the depth stream or just the audio streams. So very interesting combinations, but lots of excitement happening. I hope you'll be part of this movement too. We even have a little video that you'll start to see less commonly now, because this was part of the Microsoft Research Days as we were just getting started with the Kinect for Windows work. And we saw this as a movement that changed, not only with Microsoft people, but everybody that gets access to the SDK, people like you. So I hope you'll be part of this movement. Let me explain what some other people have been doing in the community. So we launched in June. We had a 24-hour coding marathon, sometimes called a hackathon, all sorts of other names, but 24 hours. Not everybody went to bed that night because it was 24 hours. We brought in a bunch of students and industry people to see what we could do in 24 hours with the SDK. sight unseen. They've never seen the SDK before. I'll have a slide on that in a second, let me tell you more. And in the first few months, we've started to do talks like this one. Go out into the community and share with you both our excitement, hear about what your ideas are, hear about some of your projects that you've been doing. I hope we'll hear some today, and I encourage you to ask questions and highlight that at the end. But we've visited all sorts of places around the world, and here we are today in Taiwan. The Code Camp, the hackathon that started on the launch day, was quite remarkable. We had a bunch of universities and industries, as I mentioned. I think there were 36 people total. A little story from here I'll explain. Of the 12 demos that came out of this, people formed teams of 2 and 3. Of the 12 demos, one demo was even produced by a team of students, a couple of students that had never programmed in Windows before. So now, they're pretty good students, I'm sure, but it was still remarkable to us that not only had they never programmed in Windows before, but like the rest of them, they'd never seen Kinect for Windows SDK before either. And yet in 24 hours, they built a really nice demo. And this is something that we've seen reproduced. As we've been talking around the world, as we've been hearing about your projects, people are finding this technology relatively straightforward to use, remarkably easy to pick up. And so I encourage you today to, if you've not downloaded the SDK, try it out for yourself. It's a fun technology to work with, and it's really easy to get started, build the samples. Even if you stop there, it's still a part of the experience of the leading edge, the bleeding edge of computer science today. Well worth trying, well worth experiencing. The project gallery on Channel 9, over 120 projects I mentioned today. I would love to do a talk which just went through all of these projects because they're all interesting in different ways. And I'm really glad that our colleagues here in Taiwan showed some videos from the projects because they showed some of the projects there already. So that saves a little bit of time. So I won't go through the 120. There'll be no time to hear Krishna if I did that. But do check these projects out. If you're stuck for ideas, if you try some samples, you're not sure where to go, it's really good inspiration. If nothing else, check out these projects to see all the sorts of different ideas, all the different applications that people are doing. Just amazing creativity is happening in this space. And you can be part of that. I'm sure you have ideas to contribute to this too. So do submit your own ideas. Send in your projects. Get your name in lights. One of the things that's very cool as part of Microsoft is that we have we're a big company and we reach a lot of people, talk to a lot of different people. If you use the SDK, the official SDK, and build applications using this SDK, we would love to highlight your work. So as we go talking to people about the projects around the world, then we can highlight your projects too. So do send in your ideas. The next steps, we have some contests, particularly for students. Kinect is part of Imagine Cup this year. Imagine Cup is the big student competition, undergraduate students. It's going to be, the finals are in Australia this year, so quite close by. Last year it was in America, it's been around the world. We have some pre-university work as well, starting in the US in this case. I get a little nervous about Kinect and technologies being used before university level, but the best high school students definitely like to use the SDK, and sometimes are better even than some undergraduates. They can use the SDK. It's also a testament to how straightforward this technology is to use. And we're using this in robotics, which is a very common use of Kinect today, using it as a sensor array. We're also, in this case, using it as a natural user interface. And I encourage you, if you have a robot interest, robot projects, check this out, how we're using Kinect in those. There's also local contests, and I wonder if there's any local contests in Taiwan. But many countries are doing their own local competitions. I encourage you to think about that. It's a great technology for getting people together, building a contest around. It's just so interesting, so exciting. We're doing these training workshops around the world. I'm interested in feedback from my colleagues and from yourselves about what sort of classes you would like to see. I'm sure your professors would like to hear that if you're a student here. And the big thing that's coming is in the new year, early 2012, is the commercial release, where we're releasing not only an ability to have companies use this technology, sell products based on it, build new businesses on it, but there'll be new features. and new hardware coming. So that we're really upping our game, really transforming this technology. This is not a technology that Microsoft Research has put out as an experiment, and maybe it'll work, maybe it won't. It's up to you now to use it. This is a technology that we're behind. We see this as transforming the way people interact with computers, and maybe used as interesting scenarios that exploring new product types that we've not even thought of today. So very, very cool technology. A movement for change. Be part of that movement. Come join us if you haven't already. This is the logo to look out for, the new Connect for Windows logo. connectforwindows.org is the website. Ignore the website with my t-shirt, that's the research one. That's the website to go to. This one will get to the same place, so it's not that confusing really. Let me pause there. I'm open to questions, then we can hand over to Krishna. Thank you very much for your time today. Is that a question coming? No, just camera. No questions. I have a question. Yes, at the back.
Excuse me, I have a question. There is another SDK, for example, OpenNI, which can also apply on Connect. What is your opinion about the Connect SDK from Microsoft and the OpenNI library?
Thank you. So I'll repeat the question for the video and so on. The question is asking about another SDK from OpenNI. And this is a legacy, particularly of the window of opportunity that there was while Microsoft was working on its official SDK, where the community itself saw the potential of this technology and wanted to make available this technology to everybody. So I can really only speak to the official SDK from Microsoft. And the Kinect technology, the Kinect hardware, is from Microsoft, and therefore the SDK that we've released is the one that I would recommend. I also think that we are showcasing the best work that we can of our own work, particularly on the algorithms around the skeletal tracking. You'll also see us add new features. I can't get into all of those features today, but there are some top asks from the community about what things they would like to see in facial recognition and gestures and all this sort of thing. We see this as very serious business because we want to make a success of this from a commercial point of view. We're not just playing around, it's not just researchers sharing a cool work. The purpose here for Microsoft is that we're very serious about making this successful. So I recommend our official SDK. I think there's great work being done by the community, and I respect that nicely. I think there's room for open source approaches as well as open source approaches. I think it's a free world in this area, and I think it's perfectly acceptable for myself as a research person. But Microsoft can really only endorse the official SDK. It's the technology that we've designed. And if you want to leverage the best technology that we're working on, then that's the place to come. Thanks for the question. No other questions? You're all keen to hear Krishna, I'm sure. That's good news. That's good news. But I'm happy to have any further ones. If there's not, then no pressure. That's fine. Should we have a quick pause and then over to Krishna? Does that work? Okay, well thank you again very much for listening to me today. I've enjoyed talking to you. It's my first time in Taiwan. It's been great to visit. Thank you very much.